3, 2, 1.
What my research involves is a blood serum diagnostic protein by the name of alanine aminotransferase. Typically, this is used as a liver disease diagnosis protein. They draw the blood, and if it has elevated levels, the first thing they look towards is liver disease. But recent studies have kind of indicated that alanine aminotransferase, ALT, is involved with heart disease as well. They've done different studies involving children or different ethnic groups or different things, and it's never been on a large scale to really determine any mechanisms or the direct impact. But there are trends that kind of suggest that there is an impact here. So what I'm doing is analyzing this data set that we have from the CDC, which is the government, which involves 7,000 participants, and they took and measured ALT along with many other different things, and I'm using that data to kind of determine if perhaps there's an impact on ALT in cardiovascular health. So like I mentioned, I'm using this 7,000 person data set. It's called NANES, the National Health and Nutrition Examination Survey. This was done in multiple years, but the one I'm particularly using is from 2003 and 2004. So how do I use ALT to determine cardiovascular health? Well, the easy plan would have been, okay, who had ALT elevated and then did they have heart disease? But you can't really do that if your time span is only 7-8 years from 2003 to 2004 to now, because they may not have had their cardiovascular disease or whatever. So I looked at different ways to kind of determine this, and one of the things I came up with was using other blood serum proteins that are diagnostic proteins that are specific for cardiovascular disease. And I have 5 of them that I'm going to look at and compare to ALT: C-reactive protein, creatine phosphokinase, troponin 1, high-density lipoprotein, and low-density lipoprotein. And the 2 qualifications that these proteins needed to meet was, the first one, they needed to be known diagnostic tools for cardiovascular disease. They have to have a known impact on CVD, cardiovascular disease. And the second is that they had to be available in this NANES study. If they didn't measure it, I had no way to compare it. And what you see in the image here is alanine aminotransferase's protein structure. So my hypothesis was basically this: if ALT is elevated, the other proteins will also be elevated. Therefore, ALT, in some correlation, has an impact on cardiovascular health with heart disease. And the reason why is because ALT is a tissue damage protein, and it is only in the liver, the kidneys, and the heart. And this is kind of why people have been moving in this direction. So it's general cardiovascular health with 5 response proteins: the CRP, the CPK, troponin 1, HDL, and LDL, the 5 that I just mentioned. So basically what you have here is you have to do a statistical analysis, and if there is an impact, you reject the null hypothesis. And this variance within groups over the variance between groups, this is kind of the way you determine it through the test. It's a one-way ANOVA test, and I'm kind of modifying that, and I'll go over that in a second. Basically, if ALT has an impact on these groups, the variance within them will be pretty small depending on the ALT levels, and the variance between them, comparing the groups, will be large between the different ALT levels, saying it has an impact and we can determine specifically the impact. And the smaller the variance within groups and the bigger variance between groups means we reject the null hypothesis. There's obviously some sort of impact of ALT on these proteins. So what you have to do is you have to determine the type of variables you have. The first thing is that we determined that ALT was qualitative data. We split them into 4 quartiles, and then we compared them with 5 quantitative variables. And what you do is to account for interaction between them, you have to realize that we have to do a multivariate analysis. And we use statistical package software, SPSS, to do this. Basically, my timeline is pretty simple. I expect to be done with this by February. I have all the things that I need: the tools, the data set's free, SPS is free, and along those same lines, my budget is also free. There are no perceived costs to this experiment. Basically, if we can reject the null hypothesis, then ALT correlates with cardiovascular disease. This is an important finding because we can use ALT as a different diagnostic tool. We could perhaps see patients with elevated ALT that don't have liver disease and realize maybe it's a heart disease. And we can kind of use this to know more about the mechanism and determine what kind of things are causing ALT to correlate with the CBD.